My name's Jack.
And I'm Patrick.
And this is our 3140 final project, line file and car.
This is a close-up view of the hardware of our project. As you can see, we had a previously existing wheelbase that we built up all our electronics and wiring on top of to create our final project. In order to do this, we used a Freedom board in order to do our central processing for the project. This is attached via ADC to the two line sensors. Also, we have a level shifter that helps facilitate I2C communication for Freedom board and the Arduino Uno. The Arduino Uno is used for PWM control for the motor controller. We also have a 12-volt battery connected to the motor controller, which allows us to power a whole board. We also have 4 motors, as you can see here, that are driven from the motor controller, and a 3D printed L bracket there, used for mounting the line sensors and LED array in order to get resolution while following the line. We also have this LED controller for tuning the LEDs, which wasn't used in our final iteration. We also wanted to use a second Freedom board initially, but due to time constraints, ended up only using one.
When we were setting this up, we used the scheduler from our previous labs, and we have 3 different scheduled processes. First, we have the ADC read, where the Freedom board is reading the analog values from the 2 line sensors over ADC1 and ADC0. The line sensors send this analog value, which the Freedom board then stores as a 1 or 0 based on whether or not it thinks each line sensor is on the line after it compares to a threshold value. Our second process is where the Freedom board compares the ADC the line sensor values to translate to motor instructions. So here, if you have say the left sensor thinks it's on the line, then the Freedom board will decide to turn right in order to keep the robot on the line. It does this. We have 3 different modes. We have right turn, left turn, and straight in order to keep the robot sort of wiggling around the line the whole time. The final process is sending these motor instructions over I2C to the Arduino. Here we set up an I2C protocol where we have first a 1 or a 0 to represent the direction of each motor and then the speed. So we send 4 values total. The Arduino then expects this series of 4 values. So when it reads, it goes direction, speed, direction, speed. And then the only thing that the Arduino board does is read these values, translate that to PWM to send to the motor controller. So for testing our system, the first thing we did was set up the serial monitor. We set this up with PuTTY, as the video described, and this was instrumental in our testing process. This was really useful because this is an embedded system, and we're doing things in real time with sensors. We were able to get real-time data readouts from the line sensors, and especially when we were doing I2C, we had the PuTTY serial monitor open on one side of the computer and the Arduino serial monitor open on the other one. And this allowed us to get data from the sending side and the receiving side right at the same time, which was really helpful in debugging the system.
Another key component of our testing was a modular style of testing. We executed this with 3 main phases of testing: initialization, tuning, and scaling. For initialization, one example of this was in our I2C protocol. Originally, we needed to start out by making sure we could receive the Arduino I2C as we wanted to, so we set up 2 Arduino Unos and sent information over the 2 using the I2C protocol, and we included wire library for Arduino. Using this, we were able to effectively get results on the Arduino. And then we also used the Freedom board to set up the I2C in order to see if we could actually get results from that. In order to tune it, we then wired the Freedom board with the Arduino Uno and sent distinct values over the Freedom board and Uno to make sure that we could actually get receivable results from the Freedom board to the Arduino, and that we could get results changing over time to send effectively from the Freedom board to the Arduino. And then in scaling up, we got the Freedom board to send, we changed the protocol and sent larger chunks of data, as Jack pointed out earlier, 2 directions and 1 speed, so that we could effectively tune our motors and get a working system according to our specifications. Using this, we were able to, in this process, we were able to integrate a lot of systems and test them in a good way, and to get good testability and tuning throughout our project. For our test cases, we used electrical tape taped on a lighter background in order to create good contrast so the car would have a line to follow. As you can see here, this is our initial testing, using moderate curves in order to make sure that our car could effectively follow changes in the direction for the car.
And this was our challenge test case, where we had much sharper turns and quicker changes. And note especially the right angle here posed a particular challenge that we wanted to make sure we could overcome. Finally, as you saw in the video, we had a much larger setup for the loop. This made sure that the car could also smoothly work around a curved track, and also that the line sensors could be tuned for different backgrounds such as the cardboard.